In this video, I'm going to walk you through an approach to using source control based ALM or Application Lifecycle Management to enable Fusion development in Power Platform. If you review our Fusion development documentation on learn.microsoft.com, it'll walk you through the concept of Fusion development, how it's all about taking all the personas that participate in the Power Platform, everyone from the citizen developer to the more advanced maker to the professional developer to even the IT professional, and how they can play a part in low code development. It also talks about how low code and code first or pro code development can be fused together to solve problems through code first extensibility. And right alongside the Fusion development guidance is links to the guidance for ALM for developers. Application Lifecycle Management becomes an important part of Fusion development and a key capability often used in Application Lifecycle Management. Git-based source control is also an important aspect of this approach to Fusion development. And in this documentation, you'll see links to lots of tools like the Azure DevOps build tools for Power Platform, GitHub Actions, other developer tools like the Power Platform CLI, etc. And under the Implementing Healthy Project and Solution ALM section, one of the documents talks about using Azure DevOps to move from manual to automated ALM, including using source control. In this walkthrough, I'm going to bring together many of these concepts from scratch. So we'll start with the Power Platform CLI. So I'll type pack here. And what you'll see is that I already have the Power Platform CLI installed. But if you want to learn more about it, you can just go to aka.ms/Power Platform CLI. If you want to give feedback to the team, you can go to this public GitHub repo. As you can see, the CLI has many functions for doing administrative things with Power Platform, like creating environments, deleting environments, resetting environments, often things you want to do in application lifecycle management. Ability to list and install applications from app source into environments, manage your authentication profiles, work with Canvas apps, work with Catalog and Power Platform, generate code for the Dataverse APIs to have a nice, strongly typed C# set of classes to interact with Dataverse, interact with your organization, otherwise known as environment. Org is a legacy term that we're going to replace. We also have an alias for it called pack-env. And anytime when you're using pack, you can just use the noun with a help or the noun verb with a help. So pack org who help. And it'll give you the more detail of how to use the commands. You also have the ability to build what's called package deployer projects that are used in AppSource as well as Catalog for Power Platform to package up one or many solutions, import those solutions in the proper order, even ingest data as part of the deployment process, and do advanced things in your package deployer package, like change settings in the environment. For example, you might need to enable PCF for Canvas apps before you deploy your solutions because you have PCF components and Canvas apps that use those PCF components. And you want everything to be in a working state during your deployment process. Speaking of PCF, the ability to build Power Apps component framework components to extend the user experience of both model-driven and Canvas apps with components or controls that you author that can then be brought into your applications. Interacting with things like pipelines for Power Platform, which we won't walk through in this session, but is a more easy button way of doing ALM. In this walkthrough, we'll show you how to do the more lower level approach to ALM. If you need to write code behind the Dataverse API, whether it's code that responds to create, retrieve, update, etc. events in Dataverse, or you want to extend the Dataverse API, you can use .NET plugins written in C#. If you use Power Pages, there are commands for there. Solution is one of the major commands we'll be using for ALM because solutions are the package and deployment mechanism for ALM in the Power Platform. You have the ability to run UI automation tests using Power Platform Test Engine. And last but not least, you have the ability to run Pack Tool, to run tools like the configuration migration tool, package deployer itself, and the plugin registration tool. So if you're not familiar with some of these capabilities of Power Platform, I would strongly suggest you go do some Google or Bing searches and research more. There's a lot of capability in the Power Platform CLI. But to get started, we are going to create a solution. And throughout this walkthrough, sometimes I'll wear the hat of a citizen developer or advanced maker doing mostly low code things. Sometimes I'll wear the hat of a professional developer doing code first extension of Power Platform. And all along the way, I'll be using Pack CLI and Power Platform build tools for Azure DevOps to fuse it all together. So as I mentioned, we'll start with a solution, and I could start code first. I could say Pack solution. So let's open another tab here, and we'll say Pack solution help. So I'll use the more verbose flags. All right. So we're going to use Pack solution. I'm going to show you an example of Pack solution init. We're using a publisher name. So a publisher, think of a publisher as the way to uniquely identify who your solution is from. We use a publisher prefix, which is a way to also, as you are creating things in Dataverse, to uniquely identify that it came from the publisher. And then we're going to create an output directory with the name of the solution. Let's do that again. I think I misspelled publisher prefix. There we go. And we're going to open up this folder, Visual Studio Code. And the point of this simple walkthrough is that you can always start code first, although I'll show you that most people don't. But just so you understand what you get a CDS proj, which is an MS build file, much like a CS proj for C# libraries, for example. But this represents all the MS build instructions on what to do to build your solution. And then you've got metadata that describes the solution and everything that's within the solution. Now, this is an empty solution, so there's not much here. So instead of starting code first, I'm going to do what most people do, and they'll create their solution here. Similarly, we'll call this Hello Fusion Dev. Create a publisher, just like we did before. I explained what a publisher is. And we'll select that publisher. All right, now we have an empty solution in the environment. Now in this view, you don't really know that there's XML files under the hood, etc. And to most citizen developers, that should be hidden. It should be obfuscated from them. But professional developers want to know and want to understand and want to see the quote unquote source code of all of your low code assets. And the way you do that is you come to Pack CLI. Real quick, I already have a Git repo in Azure DevOps established. I have already cloned that Git repo here. We're going to check pack auth list. So I am using the right authentication profile. And then we're going to say pack env select env for environment. And we're going to look at the name here, PPA Marcus C Dev 1, PPA dash Mark SC Dev dash 1. All right, we're in the right environment now. So now I'm going to do a pack solution clone help. So you can see what the options are here. And so this will create a solution project based on an existing solution in your organization or environment, right? And so We call it clone because it's kind of like a get clone, but it's cloning your environment down to your local repo. So we'll say pack solution clone. The name of my solution is Hello Fusion Dev. And notice we've got it down here. I'm using package type both because I want to pull down both the unmanaged and managed solutions because these are zip files when you pull them down. Then I want to get both of them in their source control format so I can build managed and unmanaged solutions from source control. Then I want to process Canvas apps because I want the source code for the Canvas apps as well. All right, so this has done a bunch of things under the hood that you could do manually with PackCLI, but basically what it's done is it exported both solutions. It's unpacked them from their exported state, which is optimized for then import, and it's converted them into a source control state that is optimized for commits and human readability. So now if I do a code dot, at this point, not much different than what I showed you from pack solution init. The difference being that this represents what's in the environment versus starting from scratch and then getting it to an environment. So I'm going to do a couple things real quick that I prefer to do. This is an opinionated thing. I'm going to change this to the word both. Actually, before we do that, I'm going to go to terminal here. And notice that this is all source code. But if I go to the folder where the CDS proj is, and I do a .NET build, notice what happens. It looks at the source code and it builds a zip file. But in this case, it only built one zip file because we're in the managed state right now. But if I change this to both and I do a .NET build, it will build both a managed and an unmanaged solution. And this is important because managed solutions are deployment artifacts to test QA prod environments. Unmanaged solutions are artifacts for dev environments. So if you have a clean dev environment and you want to get the latest from source control into your environment, you import an unmanaged solution. If you want to actually deploy to your test environment, you deploy a managed solution. All right, so now that we have some initial source code, we're going to take this and we're going to commit it to my local repo, init empty solution from env, and I'm going to push it up to my remote. And now if we go to Azure DevOps, we'll see that I now have source code for my solution in my Git repo. Now, again, this is an empty solution, so let's go do something meaningful. All right, so we'll come in here, we'll say new app, Canvas app. We'll call it Hello Fusion Dev Canvas app. Rename this to main screen. We'll do the most basic Hello World Canvas app. We're going to insert a label and a button. Call this button hello. Call this label hello. Say hello. And when we click the button, we're going to set a global variable. And we're going to close that out. And then, of course, in the text box, instead of hard coding the text, we're going to put the value of the global variable. Right? It's the most basic hello world Canvas app. If I run this thing, click hello Fusion developer, there we go. Now let's get what we just did in a low code world within Canvas Studio here into source control. Right, so I just did a citizen developer type thing. Now I'm going to switch and do more of an advanced maker, professional developer type thing. So I'm going to come back over to Visual Studio Code. And this time, instead of saying pack solution clone, I'm going to type pack solution sync. And this will synchronize what's up in your environment down to your local Git repo or your local disk. So much like clone, except this time, once you've cloned, you just do sync over and over again to get things from your environment locally to your workstation in a source control friendly format. All right, now that it's done its thing, we can go look at what it did. First of all, you can see a bunch of files were added, but first and foremost, the solution XML was added, and we've got a root component that is our Canvas app. But we've also got a Canvas apps folder, and then a bunch of metadata. And then in the source folder, we can see the source code for our Canvas app. And here we see YAML, and then you see PowerFX in here as well inside the YAML. So now we have a full source code of everything in our solution locally. So again, I can come over here and I can say added Canvas app, commit, push to my remote, and the process continues. So every time I want to bring my changes that are up in my environment down locally and send to my remote repository, I just do a pack solution sync and then a commit and then a push. And I'm just doing those git commands from the easy button within Visual Studio. So let's say I want to add Power Automate flow. So I'll come over here, I'll do a very simple, again, hello world example of a Power Automate flow. We'll call this hello Fusion Dev Echo flow. Create an input. We'll say an output. Call this output. Of course, I'm not doing anything crazy meaningful in the flow here, but let's just initialize a variable. Call the variable hello, make it a string, and say hello from flow. Power automate. Thank you, Power Automate. So now we're just going to use our variable here. And we'll insert another text label. And we'll do something very similar. When we click this, we are going to set the global variable. Called hello flow to, and then we're going to call the flow. So we'll say hello Fusion Dev Echo flow run, pass in some text, keyed it, dot output. Okay, now let's edit this because I didn't actually use the input. And then we'll say input. We'll save that. All right, now if we launch this, I click say hello from flow, the flow is going to run. And so of course we have to set this to GBL hello flow. And because I'd already clicked the button, it ran, so it had already set the variable, but you get the point. If I click this button, it calls the flow and it returns the value. Okay, same thing, we're gonna publish, which saves and publishes this. Come back to Visual Studio, and then we're just gonna rinse and repeat. We're gonna pack solution sync to get the latest of my low code, citizen developer, advanced maker work up in Power Apps Studio and the integrated Flow Studio experience down. So now we've added more to our main screen. If we come over here, we can see now we also have a workflows folder, and we can see the source code effectively of the Power Automate flow. And no surprise, if you're familiar with Power Automate, you know Power Automate is a low code abstraction layer over Azure Logic Apps. So the format is the same as Azure Logic Apps. All right, so now if we go back, we now see that the solution has a Canvas app and a Cloudflow. And we now have all the source code of the Canvas app and the Cloudflow. I can validate that it will build, so I can still do a .NET build. And this time, as it continues to build the solution, right, we can see if I go, for example, reveal in File Explorer, we can see now the built version of all of this source code, right? This is the source code, but the built version looks a little bit different. So we open up managed. Yes, we have a flow in there, but there's no metadata file because that's all in these other files. Canvas app, we don't have source code for it. We just have the MS app and some metadata. Again, source code here, built version of the source code is the zip file. All right, so far, everything we've done has been effectively low code in the environment brought down into its source code format. Now let's do something code first. So we're going to create a PCF component. A PCF component is a way to write in a code first fashion a control or component that you can add to your model driven and or Canvas app, as well as a Power Pages site. I'm going to come up here and create a folder. We're going to call this PCF-SRC. So SRC is our solution source. We're going to call this PCF source. And so we're going to come in here and change directories to the PCF source. I'm going to say pack PCF init. So you can kind of see what these options are. And I'm going to give my PCF component a name. We're just going to call it hello. It's going to be mapped to data fields. I need to give it a namespace, and I want to use the React framework. And for convenience, I also want Pack to run npm install for me. So PCF components are authored in TypeScript and then transpiled into JavaScript. So we'll run -npm -install. And if we go to our package.json, we can see what node modules this uses, etc. So we're going to go cd to hello. And I'm just going to run an npm run start. And I've got a very simple hello world PCF component. Now, I'm not going to do anything fancy here. The purpose of this walkthrough is not a deep dive into any one of these topics. It's how it all comes together in Fusion development. And there are multiple ways you can get this PCF component into your environment and into your solution. One of them is pack PCF push, right? If you just want to get the PCF component into your environment. But another way is to just build the solution locally and then import it into your environment, because you want to make sure that what's local is in sync with your environment, just like you want to ensure what's in your environment is in sync with local. And so to pull things down, you use pack solution sync, but to push things up, you just import the solution. So we need to ensure that the PCF component is included in the solution. So we're going to go back. Notice we're in the directory where the CDS proj is, and we're going to say pack solution add reference. And we're going to put to our PCF source and our hello control. So before we do that, let's just say added flow and PCF. So we can see the changes here. All right, so what just happened here? If we look at the source file, we can see that we just added a reference to the PCF proj, right? If we look at it this way, it's easier to see. We just, in the CDS proj, we added a reference to the PCF proj. So now if we do a .NET build, it's going to build the PCF proj first and incorporate it into the solution. We can prove that by right-clicking, reveal in File Explorer, and we can see now that we have a controls for our PCF component, and we have a bundle.js. So it took the TypeScript of the PCF component here, and it transpiled it and bundled it all through MS Build and the .NET build process. Now I can do a pack solution import and send it to the bin debug hello fusion dev, not managed, because I want to import this into my dev environment, right? So I'm doing a local build and then bringing it into my dev environment. Now, normally you would probably just use pack PCF push, but I wanted to show you how you can build locally and take all of your changes that you've done locally collectively within your solution and bring them into your dev environment. Okay, so the solution has been imported, so we can go back up here. And now if we refresh, we see that we in fact have a PCF component in our dev environment. All right, so let's go back over here and let's just say added PCF to solution. Go ahead and push it to our remote. Let's just add the PCF to our Canvas app. To do that, you're going to need to go to the admin center and enable a setting in your environment. So I'm going to go over here, environments, to my dev environment. I'm going to go to settings, product, features, and we want to look for enable Power Apps component framework for Canvas apps. So when I save that, I'm going to go ahead and do a couple other things while I'm here. Make sure every time I build a Canvas app, it gets in Dataverse. I'm going to make sure every time I build a Cloudflow, it gets in Dataverse. And click Save. And I'm going to do one more thing while we're here. I'm going to set my preferred solution to be Hello Fusion Dev. Why did I do that? Because I set those two settings for Canvas apps and flows to always be stored in Dataverse. And then I set my preferred solution, and the combination of all of those means that anytime I create a Canvas app or a flow or anything else, a Microsoft Copilot Studio bot, etc., all of it is going to go to this solution when I do anything in this environment. Nice little tip. It's a little bit of a tangent, but wanted to call that out. All right, so let's go back here. We're going to edit our Canvas app. We're going to add a code component. And then we're going to go look for hello, which is my component. We're going to import it into this Canvas app. We're going to find it, and we're just going to drag and drop. Now I have a component that I've authored with code first running in my Canvas app. And now, so I'm back in Visual Studio. I can do a pack solution sync. And we can see that if I go to the source code of my Canvas app, we can see exactly what's changed. We are now referring to the PCF component. We've added it to our Canvas app. So I can come over here and I can say added PCF to Canvas app. We can commit this, sync it up. Now at this point, we've kind of walked through the fundamentals of Fusion Dev using source control as the mechanism to fuse the work that is low code and code first together in a single deployable unit, which is the solution zip. And of course, I can just run a .NET build on this thing locally, and I can build from source code a deployable version of what's in my environment. Now I'm going to jump to a more involved example. So if I go to github.com/dev/hello fusion dev, this is publicly available. And what you'll see is that this represents the same concept that I just showed you, but we have a PCF component, we have a .NET plugin, we also have JavaScript web resources. And if you really want to dig into this, we can look at a couple things, right? One, the CDS proj, much like it referred to the PCF proj, it also refers to a CS proj, which represents the .NET plugin. If we look at the .NET plugin, it basically gets wired up to the account entity. And every time the account entity is created, it just behind the Dataverse API executes some .NET code to prove that the plugin executed. Similarly, we've got a web resource, except this web resource is written in TypeScript. We're using Webpack to bundle the web resource. And if we look at the CDS proj, as part of the build process, we're running npm builds. And if you come back to the README, and you clone this repo, kind of explains what's going on here. You're going to have Node installed, Power Platform CLI, and the .NET SDK. You clone the repo, and then run an npm install on the web resources folder and just simply do a .NET build. So I have this already, of course, on my local machine. So I can go to cd github dev hello fusion dev. Right, there's my CDS proj. I run a .NET build. As you'll see, it's going to build the TypeScript files, transpile them into JavaScript. It's going to build my .NET assembly. It's going to build my PCF project. And if I explore this, and I go in the bin debug directory, I look at the managed zip file, you can see it's got a web resource, plugin assembly, it's just the DLL, right? It's not the source code. I have my PCF control, etc. This example happens to also have, going to the source, it also has a model-driven app. It has Dataverse tables within it. And the beauty is, as you saw here, to get all of that source code to build into a deployable solution file, you just run .NET build. Right? And as you can imagine, let's just go ahead and code this so we can view it in Visual Studio Code. For GitHub, if we want to build the solution, we do all the same things, but in a GitHub workflow, right? So we do an npm install and we just do a .NET build. We upload the artifacts. All right, so how might you do this in Azure DevOps? Go to pipelines. So we'll come over here, create a new pipeline. do a starter pipeline. We're going to put this in .pipelines slash, and we're going to call this build deploy, because we're not only going to build this, we're going to deploy it to my test environment. Change a few things here. Trigger is going to be none. We want this to be whatever runner you want. In our case, we're going to make this the Windows runner because we've built .NET DLLs, and today Dataverse only supports full .NET framework, not .NET or .NET Core. So the first thing we're going to do here is insert PowerShell. We're going to do inline. We're going to save this. We're just going to run it. All right, so we can see that, in fact, we got our zip files created. Right? We know the directory. So now we're going to come back here. We're going to edit this to deploy the solution to a new environment. To do that, we are going to use some Azure DevOps tasks my team builds called the Power Platform Build Tools. So the first thing we're going to do is we're going to install Power. So Power Platform Tool Installer right here. And then the next thing we're going to do is we're going to import the solution. Now to do that, we're going to use an Azure DevOps service connection. We're going to use one that I've already created. We're going to point to bin release hello fusion dev. And because this is a target environment, we're going to change this to the managed solution. We're going to go ahead and add this. One thing we're going to do, notice this import solution. Notice this right here, the environment URL. Right, we're going to grab this by copying it. We're going to go to variables. We're going to create a new variable. We're going to call it build tools.environment variable. So we're going to set this value. And we actually want to deploy. Let's go Power Platform Admin Center. We're going to want to deploy to this environment, mark SC dev 2, right, which is this URL right here. So we're coming over, HTTPS, boom, click OK, save. The other thing you want to verify is in this S2S apps, this is where you identify which service principals have permission to interact with this environment. So notice I have my pipelines SPN. Right, again, what does this do? It builds the solution, uses the Azure DevOps Power Platform build tools, and then after the solution is built, it imports it. So if we run this, right? All right, so the solution is successfully imported. Let's just validate that. Let's go to make.powerapps.com. We'll switch to that target environment. We'll look at solutions. We can see it's there as a managed solution. It was just imported 57 seconds ago. You can even see the solution history here. All right, so let's summarize. In this video, I walked you through how to use Power Platform CLI to do a number of things to enable Fusion development, but also walked you through some of its other capabilities. I showed you how to do a number of things in a Power Platform solution that are low code, and then bring the things that you did in the low code experience down locally as a source code experience for your solution. Then I showed you how to do code first extensibility in the form of creating a PCF component and refer to it from a CDS proj file to enable the .NET build process to build the PCF component and then bring it into a solution, all using source control as the source of truth. Get that into your environment, use the PCF component in your Canvas app, again, low code, bring that back down so source control is the source of truth, all the while showing how the .NET build process enabled this. Then I walked you through a more robust public example that does the same thing, fusing low code and code first extensibility together, but adds things like .NET plugins for writing business logic and general logic behind the Dataverse API, web resources authored in TypeScript to extend model-driven forms. I showed you how MS Build and the .NET Build process enables building the PCF component, the .NET DLL, as well as the TypeScript web resources, all into a single zip file for deployment using .NET Build. Finally, I showed you how to create an Azure DevOps pipeline that uses .NET Build to build everything with the simplicity of one call, and then deploy the thing that we've built in a managed solution state to a target environment. Now, all of these examples are fundamentally hello world. It is the basic connecting of the dots and plumbing. In more real world situations, you will do much more advanced things. But hopefully, this gives you an idea of how to enable fusion development using source control as the source of truth to fuse low code and code first development for the Power Platform. And last but not least, if you're watching this before May 21st through the 23rd of 2024, this is the most effective way to do what I've shown you. But pay attention to the Build conference because we will be announcing a number of improvements in the platform that make everything I showed you much more easy button and integrated into Power Platform. So stay tuned.